Okay, Assalamualaikum everyone. Okay, this is a lecture video, okay, for the types of probability distribution. Okay, so I'm going to explain on the types of probability distribution directly now. Okay, so for this probability distribution, there are two main types of probability distribution. Okay, that belongs to the discrete variable, discrete random variable, or continuous random variable. So for discrete, sometimes we call it a common. Okay, there are several types of discrete probability distribution. First one is called as discrete or common probability distribution, and then we have binomial probability distribution, and we have Poisson. This is three basic discrete probability distribution. And for the continuous random variable, we have normal distribution. Okay, so the one that I'm going to explain now will be based on this kind of probability distribution. Okay, I'm going to start with the example for a simple experiment. Okay, so the simple experiment is when we toss a coin twice. Okay, so when we toss a coin 2 times, so we have the X outcomes. So the X in this situation is defined as the number of heads. Okay, so this is for the simple experiment. Okay, so please take note the meaning of X. Okay, that is our discrete random variable can be changed. Okay, for example, the number of tail. Okay, but in this kind of example, so the X is defined as the number of heads then turned up when a coin is flipped twice. Therefore, the one in this table is the possible outcomes, and we find its corresponding probability. Okay, so for this one, first toss we have head and second toss we have head. Therefore, X is 2. Okay, so this 2 means when we got 2 hits after the toss. Okay, then second outcome, first toss is head, second is tail. Okay, we have one case. First is tail, second one is head, then we have 1. Then when we got tail for the toss, then X refer to the value of 0. Okay, so to find out the probability, this is given here. They are having probability as 1/4. Okay, means that there is one case when we get both hits out of 4. So this is our number of sample space. So please take note that the summation of this probability or in this column is equal to 1. Okay, which follow the rules of probability. Okay, so the one in the table, we can write down to the one in the probability distribution. So we have X, then we have PX. So X, we sort actually start from 0, 1, 2. So PX, when we have case 0, will be based on this one. So the value is 1/4 Okay, or you can write down in the decimal numbers as 0.25. Okay, for the case there is 1. Okay, so we sum up this case, their probability. So we have 0.25 plus 0.25, then we have 0.5. And for the case when x is 2, means that we are getting both hits, and it is equal to 0.25. So the total here will be equal to 1. Okay, so this we call as probability distribution table based on discrete or common probability. Okay, so in this probability distribution, either it is in discrete, common, binomial, Poisson, or we can have in normal. Okay, the summation for px will be equal to 1, and the value for the px, okay, px means the probability value lies between 0 and 1. Okay, so I'm going to show another example for this table. So number of cars dealer is selling daily means the x value. So the probability distribution table will be shown like this. X and px. So 0 we have 0.05. This we get as 5 divided by 100. For case 1, we have 0.15. For case 2, we have 0.35. For case 3 is 0.25. For case 4, we have 0.2. Then you can check that the summation is equal to 1. Okay, so like the one in silo number 1, so we can calculate their expected value and also variance or standard deviation. Okay, so I'm going to explain the formulation for this expected value. So this expected value also known as the mean or average. So you can use the symbol. If we call as expected value, then we can use EX. Or you can use the mu symbol or the X bar. So mu refer to the symbol for population, X bar refer to the sample. Okay, so this is a basic formulation for the mean over or the average. It's equivalent to the summation of X times PX. Okay, and then this is the rules regarding the expected value as shown here. Okay, so basically we rarely use this kind of laws, okay? And this is the formulation for the variance given in the box. So to find out the variance or standard deviation, make sure we find first what is the value of the mean or average. Okay, so for detail, I'm going to show to you the example after this, which is this example. Okay, so we have this table given. So there's a question to find out the expected value and the standard deviation of X. Okay, that refer to the number of cars sold. So we find out first the expected value or the mean or the average. So the symbol will be, we can use EX. Okay, so the formula is summation of X times PX. Okay, so the one in this table, I'm going to write down into the vertical table like this. Okay, so this is the column when we multiply the value between X and PX. So here we have 0, which is 0 times 0.05. Next, we have 0.15. Okay, next we have 0.7. So this is 0.75. Then we have 0.2. So this is 0.8. So the total for the column x times px will give us the expected value. We have 2.4. Okay. So therefore, the expected value is equal to 2.4. Okay, next to find out the standard deviation, expected value is equal to 2.4. So this is our mean or average, correct? Okay. So to find out the standard deviation, first we will be using formulation of variance. Okay. So the variance, I'm using symbol S squared because this is actually sample case, right? Is equal to the summation between x minus x bar. So this is actually the x bar, right? Squared times px. Okay, so the one in the table you can write down like this. Column for x and px. We have x minus x bar power 2. Okay, 10 times px. So I'm going to write down again. Okay, so the calculation here will be 0 because, okay, the calculation. Okay, so now we are going to calculate for the first part. Okay, so this means, let me change the colors first. This means 0 minus 2.4 squared times 0.05. Okay, so you have to simplify this. So first one we have 0.288. Okay, so we do similarly for the next one. For x1, so this part for this column, the calculation is now we have 1 minus 2.4 squared. Okay, so in this case, we have 1 minus 2.4, our mean just now. And then in the bracket to the power of 2 times 0.15. Okay, so I'm going to show to you directly what is the calculation in the table. So we have 1 minus 2.4. Then we have squared. Then times 0.15. So at x1, we have 0.294. Okay, for this level, we have 2 minus 2.4 and then squared, then times 0.35. Its value is 0.056. Okay, for x3, we do as 3 minus the mean power of 2, then times 0.25. So we have 0.09. So the last one, we have 4 minus 2.4, then power of 2, then times 0.2. So here we have 0.512, then get the total for this column. So the total here is 1.24. So the variance is 1.24. So the standard deviation is square root of 1.24. That is equal to 1.114. Okay, so this is when we round off correct to 2 decimal places. Okay, so that's all for the topic. If you have any question, then please drop by your question in the website group.